Hello everyone, my name is Minjae. I will teach you guys about electronic circuit EC3207. The textbook is Fundamentals of Microelectronics written by Professor Razavi. We will learn from chapter 1 to chapter 9. And in the second semester, you will have a chance to take advanced electronic circuit that is offered in the second semester. So throughout this semester, we'll learn about the microelectronics. Micro means very small, right? Micro scale level, and small electronics. So what are they doing nowadays and why we are learning about this? Think about we are living in a world like analog world. Everything around us is analog. For example, heat, sound, light, and wind. We can define those things by several features like the intensity. The heat can go higher or lower. Sound can become louder or smaller, right? It has some different intensity, and also it has some variation, right? So everything we are dealing with every day is analog. But we have a computer or electronics to process all the information from real world. To do that, what we have is that there is some sensor there that converts the analog information in electrical signal, right? The signal waveform looks like this, up and down, right? It has up and down. But because of the I'm sorry, everything is not ideal, meaning there's just some the noise in it. So out of the sensors, the output will be very noisy, right? Or the signal level may be distorted, right? It may not represent properly the signal, analog signal, right? It may have some poor representation of the signal on top of the noise. The first, in the analog side, we may try to eliminate all those noise or distortion so that we try to replicate more clean, try to generate a more clean signal. And then once we get that out of the analog signal processing, we'll convert that analog signal into digital signal like a 1 and 0. So a bunch of 1 and 0 signals is represented in digital domain. So there is the block, interfacing block called ADC, analog to digital converter. There's just some example of the analog signal processing we learned. Amplification and filtering and modulation, all those things trying to recover the artifacts out of the sensor or front-end electronic or devices, right? Once that information is converted into digital domain, all the work goes into the digital guys. The digital signal processing involves, you can imagine, plus, minus, division or multiplication, all these arithmetic operation. Or in C program, you may think of some conditional statements like if and else, or case statements. All these controlling flow, right, can be easily done in the DSP. And also there's also the bunch of the memory and flip-flop and latches. all those memory storage and data storage store the data for further process, right? Once you calculate or once you process data, one step, and then later you have to pre-calculate the data onto the memory, bunch of memory, and then later on you may retrieve the data again and then process again, right? And then move the data back to the memory, or you may transfer that such data throughout some data communication to someone else far away from me, right? All these data communication it can be either wireline communication or optical communication. So using the light, the speed of light is so fast, and you can make a very high speed the transmitter in optical domain, or it can be the wireless signal. To transmit the data, we may first convert the digital signal back to analog. To do that, first we have to go through the digital to analog converter shown in here. Once that after the digital to analog converter, the output waveform is like this kind of stepwise, like a quantized signal, because the level of the analog signal we can generate out of a DAC is limited. The number, for example, if the DAC is 10-bit input, the case of the output level is 2 to the power of 10, approximately 1024 levels. But in real world, the levels are not quantized. It is continuous waveform, like a smooth, nice waveform. To make this smooth, nice waveform, we have to go through another analog signal processing, like a filtering. We filter out all these like a stepwise noise, quantization noise, so we generate a more nice, smoother waveform, right? To deliver that data, we may apply some modulation technique for example, in RF throughout the air. If you want to transmit the data throughout the air, you cannot transmit in the very low frequency. You have to use the very high frequency tone to deliver throughout the air, because the physical dimension, antenna size, is like inversely proportional to the frequency, you can imagine. So let's say for Bluetooth, every day you are using Bluetooth device, it uses like around the 2.4 gigahertz frequency range. So we convert modulate. We call this operation is modulate. The baseband low frequency data is modulated by the high frequency 2.4 gigahertz. Then the output waveform looks like this. So we make it. This is just a multiplication of the two signal. So, and once that is multiplied, the output signal becomes very high frequency tone. We will send it through the antenna and receive that signal on the other side. We go through the same process we have seen on the upper right hand side corner. So we do the same thing. We again convert the analog to digital, and again in the digital side we do all kinds of the digital operation. And again, if you want to send our signal back to myself, then we go through like this kind of all these operations. As you can see, the microelectronics deal with deliver analog world signals to the to the digital domain, and inside the digital domain we can do a lot of things. So nowadays all the digital functions are implemented by the CMOS technology, meaning it used the CMOS devices or transistor. CMOS transistor, the size of the transistor becomes smaller and smaller. It becomes easier to integrate many billions of a transistor in very small area. That means you can put more digital function into very small area. For example, like 1 millimeter by 1 millimeter, for example. In this kind of a small size of the silicon inside here, we can put actually billions of the transistors inside. What are they doing? They are doing either analog both analog processing and digital processing, right? It is doing all the function as I explained in this slide, right? So as the process technology develops, we can put more and more function, meaning there's just some trend there, analog signal processing. We would like to replace that by the digital signal processing more and more. So one may think of, then there is no analog engineer needed anymore. So no, that's not true. We need analog engineer because analog circuit engineer is always must be there. Why? Because the actual real world is analog. We have to deliver analog signal to the digital domain. So interface circuit is always analog. So you have to learn about the analog circuit. That's the key and the inevitable block, and most critical and also block. Okay, because that the performance on the analog circuit mostly determines the overall circuit or overall system performance usually. So it is very important to learn about the fundamental and principle of the device and also analog circuits. Throughout this course, we will learn about this. That is the key and basic foundation for you to move on to the next level. Okay.